Comparison operators are extremely important in the design of useful queries. You might not know them by that name, but I'm sure you will recognize them once you see them. They are the equals, less than, and greater than symbols. And by combining two different symbols, you can get less than or equal to, greater than or equal to, and not equal to, which is literally the less than and greater than symbols together. There are a few that use the exclamation point that you can use, but they are not standard. They are not equal to, not less than, and not greater than. This format is not common, but you might run across them when exploring queries in databases that other people have made. So it's a good idea to be familiar with what they are. I recommend sticking with the standard formats when writing queries in SQL Server. So let's see this in action in a couple of queries. I'm going to create a new query and select the name, the tax rate columns from the sales tax rate table. I'll execute the query and I'll get the results down below. There is a total of 29 different records in the table. To return just the records that are equal to specific value, you can add a where clause to the end of this, such as where the tax rate is equal to 7.25. I'll execute the query and it shows the two rows that have a tax rate that exactly matches our criteria. You can find the records that are above or equal to 7.25 by changing the comparison operator to where the tax rate is greater than or equal to 7.25. When I execute this shows me the 14 records that are either 7.25 or above. If you want to find records in a range, you can string two predicates together with the AND or logic operator. For instance, if you wanted to find the tax rates between 7 and 10%, one common tipping point is that each predicate needs to be a complete logical statement. So for instance, if I type where tax rate is greater than 7 and less than 10, this statement is how I might think about the range that I want in my head. But if you run this, SQL Server is going to generate an error. If you want to focus on each predicate individually, maybe put parentheses around each one. For instance, here's the first one that starts with the tax rate greater than 7, and we have the second one here. This should help highlight the problem. The first predicate is greater than 7, and this is complete and fine. The second one though just reads less than 10. Hopefully this helps you recognize the issue. We need to be specific about what value we are comparing here. So we need to add another reference to the tax rate column again in the second predicate to make this a valid query. Now it reads where tax rate is greater than 7 and the tax rate is less than 10. This query will just return the records where both of these predicates are true. When I execute it, I see I get a total of 7 rows that match that criteria. Keep in mind though, this statement isn't inclusive, so you're not going to find rows that are exactly 7 or exactly 10, just the ones in between. If you wanted an inclusive range, you would need to use the greater than and equal to and less than and equal to symbols. Now when I execute it, I'll see every row that's between and including 7 and 10, and you can scroll through the results to see the full list. And that's how you would use the mathematical comparison operator symbols in your queries.